Hey, welcome back to Rashid channel. In today's video, I'm going to show you how to design and calculate a capacitor bank. A capacitor bank, also known as power factor correction panel, is used for maintain an optimal power factor in electrical system. Simply we can say it reduces the amount of reactive power and thus improve efficiency. When your power factor is low, your system use more electricity, which increase your energy bill. Installing the capacitor panel helps improve the power factor, reducing electricity consumption and avoiding extra charges from the utility company. Here you can see, when you connect capacitor bank to inductive load, the reactive power decreases, which reduces the total apparent power. As a result, the power factor improves, making the system more efficient. Before we jump into the calculation part, let's understand the key parameters that affect the design of capacitor panel. We need three important values. Number one, total load in kilowatt. This is the amount of active power your system is consuming. Second, existing power factor. This is the current power factor of your system. Desired power factor. This is the target you want to achieve. Typically it close to 1. Sometimes it's 0.95, 97, 98. Depends on your requirement. Fourth one, voltage. The operating voltage of your system. Now let's take an example to understand this better. Here we have an electrical system in which active power is 200 kilowatt. System voltage 415 volt. Existing power factor, that is cos theta 1, is 0.75. Desired power factor, that is cos theta 2, equal to 0.95. To calculate the required capacitor bank size, we use this formula. QC equal to P multiplied by tan theta 1 minus tan theta 2, where QC is the capacitor size in KVAR. This is the size you needed. P is the active power in kilowatt. So first we need to calculate the angle theta corresponding to the power factor. To substitute value in the formula, we first need to find the angle theta 1 and theta 2 to calculate the size of the capacitor. We know the existing power factor is 0.75. That is cos theta 1 equal to 0.75. Using trigonometry, we can find the value of theta 1. To do this, we take the inverse cosine of 0.75. You can easily find the inverse cosine of 0.75 using a calculator. Let me show you how. After calculating, we got theta 1 equal to 41.41 degree. Same way we can find theta 2 value through desired power factor. So we have cos theta 2 equal to 0.95. Then theta 2 equal to cos inverse 0.95. And we can find the value of cos inverse 0.95 through the calculator. Which is equal to 18.19 degree. Now we have both angle theta 1 and theta 2. Now substituting the value in this formula, that is QC equal to 200, this is the power in kilowatt, multiply by tan theta, we can write 41.41 degree because theta 1 equal to 41.41 degree as we calculated here, minus tan 18.19 degree, it is theta 2 value, what we calculated here. Now QC equal to 200 multiplied by, we need to calculate the value of tan 41.41 degree. So through this calculator, we can calculate tan 41.41 degree. The value is 0.8819 minus tan 18.19 degree. Let me calculate again. The value is 0.3285. So we will write here. After solving this equation, we got 110.68 KVAR. So this is the capacitor size value. But it is advisable to include a safety factor to ensure reliable operation. A safety factor of 10 to 20% is added to the KVAR to ensure good system performance. Let's add 10% safety factor to the above example. So after adding 10%, we can write here QC final 110.68 multiplied by 1.10. This is 10%. After solving this multiplication, we get 121.7 KVAR. So rounding this, we get approximately 122 KVAR. Now we need to select capacitor with the rating of 122 kVAR. Now we would select capacitor bank to match approximately 122 kVAR. For example, 2 unit of 50 kVAR, which total 100 kVAR, 1 unit of 25 kVAR. This combination provides 125 kVAR. So this is the proper size of our capacitor bank. Now the final step, ensure to install your capacitor panel with appropriate protection device like fuse or circuit breaker. The calculation of fuse or circuit breaker using the formula I equal to QC divided by root 3 multiplied by V, where I equal to rated current in ampere, QC equal to capacitive kVAR, what we have calculated earlier, V equal to voltage. Through this formula, we can find rated current. So we can substitute the value of QC as we calculated QC equal to 122 multiplied by 1000 because we need to convert into VAR. So this is the value of kilo K. Now divided by 1.732. This is the value of root 3 and multiply by, we have voltage 415 volt. After solving this equation, we get 169.7 ampere. But there are some factors which will affect the final current flowing through the capacitor bank. Number 1, capacitor tolerance. Capacitor bank come with certain tolerance range. According to international standard, the tolerance can be range from 0 to 15%. What does this mean? Let's say you have a capacitor rated at 100 kVAR. Due to manufacturing tolerance, the capacitor might actually behave like 115 kVAR unit in some cases. If the capacity increases, the current will also increase. The circuit breaker has to be sized to handle this higher current. Second factor, voltage tolerance. In most cases, the supply voltage may vary, usually by 5% to 10%. If the voltage increases, the current drawn by the capacitor bank will also increase. For example, if the voltage goes from 415 volt to 430 volt, the current drawn by the capacitor bank will rise as well. This is why we account for voltage variation when selecting the breaker. Third factor, harmonics. Harmonics are the another key consideration, especially in modern electrical system with non-linear load such as variable frequency drives, computers, and other electronic equipments. Capacitor provide a low impedance path for harmonics, which means that they can draw extra current due to the presence of these harmonics. It's estimated that harmonics can increase the current by 20 to 35%. So, when we select a circuit breaker, we need to account for the additional current. This helps protect the system and ensure the breaker can handle any extra load caused by harmonics. And the fourth factor, inrush current. We must account for inrush current when the capacitor bank is first switched on. This current spikes can be 6 to 10 times the normal operating current depending on the system configuration. While this inrush current lasts only for short duration, the breaker must be able to handle it without tripping. So for our calculation, we will assume 15% capacitor tolerance, that is 1.15, 10% voltage tolerance, that is 1.10, 20% harmonic impact, that is 1.20. Multiplying this factor gives us total correction factor. So the total correction factor equal to 1.518. This is the total correction factor which we'll consider while the selecting of circuit breaker. Now we apply this correction factor to the rated current. We have rated current I equal to 169.7 multiplied by 1.518. This is the correction factor. So after multiplication of this correction factor in rated current, we get 257.6 ampere. So this is the size of circuit breaker. Since circuit breaker comes in standard size, so we round up the next available size. In this case, the nearest standard circuit breaker size is 300 ampere. So for 122 kVAR capacitor bank, the correct circuit breaker rating is 300 ampere. Well, this is the easy method to calculate proper size of capacitor bank and its circuit breaker. I hope you like this video. If you have any doubt or queries, please mention them in the comments. I hope you already subscribed my channel. See you in the next video.